Look at number 4, question number 4 in paper 2. We are given the y equals to 1 over x minus x. We have to find d2y by dx2, second order of derivative. Now, before we start differentiate the y, make sure we write the y in terms of index form. It's easier to differentiate this way. Okay, so let's differentiate now. So dy by dx will be, bring the power down to the front of the term, and then reduce the power by 1. So we have negative 1 minus 1, we have negative 2. All right, next, minus, yeah? Reduce the power by 1, so we have 1 over here. Next, this is only first order. The second order of derivative will be d2y by dx2. Okay, let's continue to bring this negative 2 down to the front. So we have negative 2 times with the negative x, reduce the power by 1, negative 2 minus 1 become negative 3. And then this one, after we differentiate, becomes 0 when we differentiate the constant. So all in all, we will have negative, negative become positive. And then the x to the power of negative 3 will now, let's write in the denominator. So it will be x cubed. So we have found the answer for the second order of derivative. That is for part A. Now part B, we are given y and also the equation of the normal to the curve. All right. And it's at P. So we need to find the coordinates of P. Yeah? Let's put this information in the on paper. Okay, so we have y is the equation of normal. So when you see the keyword normal, the curve, then we use this one. This is 4b. We use this diagram to help us. All right. And then the equation of the curve we know. All right. And this equation is actually equation of the normal. So let's draw the normal line first. Normal make 90 degree to the tangent. Yeah. And then the equation we mark like this. This is the equation of the normal. That is y equals to minus 1 over 8x. And then plus 19 over 16. Plus 19 over 16. Okay, what other information? Is the equation of the normal to the curve. So at the curve, beside the curve, let's write down the equation of it. It is 4x minus 5 and then squared at P. That means the normal made from the point P. So what is the coordinates of P? We don't know. So let's put it xy. x1, y1. That shows that the value can be found. Huh? So the first part of the question, only one part. Just find the coordinates of P. So how do we do? So let's look at information in hand. We have the equation of the normal. So from the equation of the normal, this is already in the gradient form. We will know that the gradient of the normal is negative 1 over 8. Now, if gradient of normal is negative 1 over 8, therefore, gradient of tangent will be, if this is negative, this is positive. If this is 1 over 8, this will be 8. It's actually come from the formula of m1 times m2 equals to negative 1. So from here, one of them is the negative of its reciprocal. So we don't have to show this one out. We just go straight to identify the gradient. So the mt is the gradient of tangent. And from here, we know that this line representing the gradient, the tangent. Therefore, mt is dy dx. You must know this one. That means when you come down, you reduce the power of y, it will gives you the gradient of tangent. So let's start with this one. So over here, gradient of tangent is square of this. Let's do it here. So we have outside. This is chain rule. So let's do outside and then followed by do inside, which is 4 only. When we do outside, inside is untouched. So let's just copy it. So we will have 8 times 4x minus 5. This is the function, the function of the gradient of tangent. Now, be more specifically, we have to substitute the x in. But the problem is I do not know the x. Never mind, but I do know that my gradient of tangent, which is over here, is 8. So with that, let's put them. We know that gradient of tangent is 8, and gradient of tangent is found to be 8 4x plus 5. Sorry, it's minus 5 equals to 8. Therefore, 4x minus 5 equals to 1. So 4x will equals to 1 plus 5, which is 6. Therefore, x will be 6 over 4, which is 3 over 2. Once we know x equals to 3 over 2, what can we do? You see, they are actually related to each other. You reduce the y, you get empty. And then if you substitute the x into here, you can find the exact value of gradient of tangent. If you substitute this point into the curve, then we will have the points. We can find the point. Okay, so what do we do next is we substitute the x that we just found, because x we just found to be 3 over 2. So substitute x equals 3 over 2 into the curve. Okay, so whenever you see y, don't know yet. The equation of curve is 4x minus 5, and then we have to square it. And then the x that we have just found is 3 over 2. So let's put this in and simplify. So 2 times 3, we have 6 minus 5 squared. So 1 squared is still 1. Therefore, we just found the point P. That is 3 over 2 and 1. That is the coordinates of P. So that is how we solve the question number 4.